Hey guys, welcome to CodeChef's YouTube channel. The problem that we are going to discuss today is crossing blocks. The problem appeared in August 21 lunchtime and has a difficulty level of easy medium. There are no prerequisites to solve this problem. The problem statement goes as follows. Chef is given a sequence of blocks with heights A1, A2 up to AN. That is basically an array is given to Chef. Now it is given that initially Chef is present at the first block and he wants to reach the nth block. That is from the first block he wants to reach the last block. It is given that he wants to do that using minimum number of moves. So till this part, I think the question is clear. Now, let's define what a move is. So, in one move, chef can jump from the ith block to the jth block only if the following conditions are satisfied. So, there are total three conditions. That is, first of all, if he is jumping from I to j, that is from position I to j, I should be less than j. Okay, this is the first condition. Second condition is that the height, that is ai, should be greater than or equal to aj. Remember, the heights can be obtained from the given height array. We have the height array with us initially given as input. And also, if there's a jump from index I to index j, all the in-between elements, that is for k that lies between I and j, ak should be less than or equal to aj. So if all these three conditions are satisfied, then only chef can make a move, that is he can jump from AI to AJ, that is from position I to position J. Given all this, we have to find the total minimum number of moves chef needs to perform so that he reaches the last block. So we have a sample example with us. The sample example is as follows. The given array A is 20, 16, 13 and so on. So in this case, the answer actually comes out to be 4. That is, in 4 moves, chef can start from the very first block and reach the last block. How? Chef can jump from 20 to 17. From 17, he can jump to 15. And from 15, he can jump to 8. And from 8, he can jump to 7. So total 4 jumps were required, and as you can see, there is no other possible answer that is less than 4. So this is what the question is all about. Now the first hint that comes in my mind is that I can imagine a diagram that how the jumps are going to look like. Right now you can only see the numbers, but if you try to draw, let's say, a graph, by graph I mean just the points. So the height 20 is somewhere over here, then there is height 17, then there is height 15, then there is height 8, and there is height 7. So the jumps are only going to go down. That is, the height is only going to go down. Why? Because of this condition, this second condition, ai should be greater than equal to aj. So at each jump, either we are going to the same height or a lower height. So no matter what, we are only going to go down in terms of height. So this is what the diagram or a first hint that comes to my mind. Let's formally see what is the solution approach. The solution approach goes as follows. Let's say the optimal path, that is our final answer, is from position P1 to P2, then P3 and so on till PL. So these are some indices on which we are going to make our jumps. So definitely P1 has to be 1 because the chef starts from block 1, and the last position, that is PL, it has to be N. The other ones are the intermediate ones, but definitely they are distinct from each other. So say this is the optimal path given to us. So what extra information can we infer from this given thing? So let's take a general consecutive positions. So that is, say, position Pi and Pi plus 1. So chef is going to make a jump from Pi to position Pi plus 1. So the heights at these respective positions are going to be, the height at Pi will be A of Pi. The height at Pi plus 1 will be A of Pi plus 1. Now, according to the question, the move is valid or the jump is valid only if this height is greater than or equal to A of Pi plus 1. This is one thing. This is the first thing that I know. Second thing is that for all the indices that lie in between, their heights are going to be less than or equal to a pi minus 1. That is for all, like if I draw a graph, let's say this is the point pi, this is the point pi plus 1. This is the height over here, this is the height over here. So all the points in between, they are going to have the height which is less than this height, correct? Because according to the question, only then it is a legal jump. So using these two facts, what we can say is that this height API, okay, let me write it below. Using these two facts combined, we can say that this height A of Pi is actually the maximum height among all these heights, right? As you can see from the diagram as well, the jump was made from here, that is, this is position Pi, this is position Pi plus 1. So the jump was made from here to here, and all the heights in between are definitely below this dotted red line. So definitely A of Pi, that is this height, is maximum of A of Pi, and all the heights in between all the way up to A Pi plus 1. So this is the first thing that we get mathematically from our assumption, that is the optimal path is P1, P2, P3 all the way up to PL. Let's see what more information we can get from the same. Now, the first result that we got, that is A of Pi is maximum of A of Pi till A of Pi plus 1. This result can be extended as well. So this result says that in these two positions, the left one, the height at the left position is the maximum one. But this is also applicable for all the consecutive pairs, right? That is, in this pair also, this height is the maximum. In the other next pair, this height is maximum. So if you combine all these, you can get an extension of our first result, and that result is going to look something like this. So let me write the second result that we are getting. So A of Pi, initially we were saying it is the maximum of A of Pi till A of Pi plus 1. That is only the consecutive positions in which we are jumping. But actually, if you extend the result in all consecutive pairs, you will see that it is not just maximum in the consecutive ones, but till the last one. That is, it is maximum from A of Pi till the very last one, that is A of PL. So what do we mean by that? If the A of Pi is, let's say, 100, there cannot be any other position in the upcoming elements that is greater than 100. So 100 has to be the maximum one. Okay. So earlier it was from A of Pi till A of Pi plus 1. Now it is from A of Pi till the very last position, that is PL. Instead of PL, you can also write N, because we definitely know that the last position is nothing but N. So this is our second finding, or the second result you might say, which we have made use of our first result and extended it to get this. Now using these results, we are going to get close to our answer, that is going to tell us exactly how the jumps are going to be. Because remember, we just don't want the number of jumps, we also want to minimize their number. So let's see how to do that. So slowly we are getting towards the final answer or the final solution approach that we are going to apply. But before that, I have a question for you. On the screen, you can see a path written by me. I want you to answer whether this is an optimal path or not. So these are obviously the heights, that is, the chef has jumped from height 15 to height 12 and so on. So these are the jumps made by chef. So I want you to answer whether this is an optimal path or not. Definitely, it is not an optimal path. Some of you might have already know that. Why? Because as you can see that here the height is 9 and again the height is 9. So in reality, we are wasting one move. Chef could have actually made the jump from this height to this height directly. So now that you know this, one more thing is obvious, that while making the jumps, the numbers should be distinct. Okay, the heights should be distinct. If you are making the jump to a same height, it is of no use. You could have directly made a bigger jump to a smaller height. That is, instead of making the jump from 9 to 9, you can make the jump from 9 to 7. So this is one thing. And another thing is that although in reality the jumps will be made from left to right direction, we will be calculating the answer from right to left. Why? Because it is easier for us. The rightmost element, let's say here, is 2. Okay, so this will be the smallest element. Okay, not the smallest element, our starting element. And then we'll do the reverse jumps. That is, we'll find the next element which is greater than 2. Then we'll find the next element which is greater than 4. Then we'll find the next element which is greater than 7. So in that case, as you can see, that the element greater than 7 is actually 9, but here also it is 9. So the jump will actually be like this. Okay, or the other way to see it is that the jump will be from 7 to 9, and the next jump can be from 9 to 12. That is also one way to see it, and so on. The calculation will be made in this manner. We don't need to actually calculate from where to where the jumps are made. Only we need is the total number of jumps, the count. So you need to take care of this thing, that these numbers are going to be unique, that is distinct. In one possible case, the numbers can be same, in which case, if you might have correctly guessed, the case wherein the highest height, let's say the first height is also 15, the last height is also 15, and in between the heights are less than 15 or less than equal to 15. In that case, you can directly make one jump from the first element to the last element. So such cases are exceptional, but other than that, the number should be unique. That is, we are looking from right to left hand side, and then we are looking for elements that are greater than the current maximum. So the current maximum was 2, then we went to the next maximum, that is 4. Then we went to the next element which is greater than 4, that is 7, and so on. So that gives us the total count of how many jumps we are going to make. And one more thing to notice is that the first element, that is the first height, should be the greatest among all the elements. Otherwise, the answer is not possible. It cannot happen that the A1 height is 15 and in between you have some height, let's say 100. It cannot happen. Why? Because there is no way you can go from 15 to 100. Initially, if you remember, when we saw the problem statement, and if you draw it graphically, the graph is only going to go down. Okay, because of the conditions given in the problem statement. So that brings us to the end of the solution approach. I hope that you guys have now understood the solution. It will be more clear once you see the implementation. The implementation goes as follows. First, we take the input for number of test cases. Then for each test case, we take the input for number of blocks, and then we create a vector and input all the heights. After that, I create an answer variable which is initially 0, and I create a maximum variable which will keep track of the current starting point of my jump if I am traveling from right to left and making the jumps in the same direction. So initially the value of maximum is -1. Then I reverse iterate the array of heights, that is starting from n minus 1 till greater than 0. Why greater than 0? You will understand. Then I check if the current element is greater than my maximum. I make that as one of my points in the path and increment my answer. That is answer plus plus, and also increment the maximum at the same time. And I keep on doing this, and in the end, when I reach the end of the array, that is the very first position, I just check if the starting element, the first block ARR of 0, if it is greater than equal to the max, current value of max. If that is the case, it means that ARR of 0, or the height of the first block, is the maximum among all the given heights. So in that case, the answer is possible, and I simply output the variable as answer, which I had calculated initially in my for loop, or else the answer is not possible. So answer is not possible only in one case, that is if ARR of 0 is not greater than equal to maximum, and that maximum is still of all the remaining elements. So pretty easy question. The only thing was to understand that how the jumps will be made, and importantly that the points in the optimal path are going to be distinct ones. That is, the heights are going to be distinct except for the in some exceptional cases, like the highest height is same as the last height. So in that case, the the heights can be same, but apart from that, they are going to be distinct. So that completes our solution.